up some hot tea, decaf tea. Do you want it? It's the Passion Tea Blend from Starbucks. I love it. It's really calming. Yeah. Be careful though, it's really hot. Here. So, how can I help you? I know you're short on time, so we don't have to talk about anything that you don't feel like talking about. I'm just here with you. It's actually perfect timing because I just finished my stuff for the day, and this is the first sort of break I've had in a while, and I'm just really happy to see you. Oh, it's not a bother at all. I promise, it's perfect timing. So, yeah, I know that you're kind of short on time. You have to get back to campus soon, but, did you want help with homework? Are you stuck on a concept or something? You're not sure? Okay, well, let's see. So you're working on limit stuff and you kind of just got stuck. You attempted them yourself. That's awesome. That's really, really great. Okay, so are you unsure about stuff, or are you feeling kind of behind in the class? Perfect. Okay, no, that's perfect. I mean, honestly, it's probably not everything. I know math can be frustrating sometimes, but you're totally capable. It's probably just a little hiccup somewhere, and we can dig through to see what concept's kind of confusing you, and then we can see if we have to go back and review a bit, or if it's just a little thing, just a little roadblock. We can do that together for sure. Does that sound good? Yeah, no, that's totally fine, because I'm not in your class, so I kind of have a different perspective, you know? I can kind of zoom out. When you're in a class, it can kind of feel like you're caught up in what's right in front of you, the test, the homeworks, but I'm not in that class anymore, so, you know, yeah, it's kind of nice, and I can definitely kind of help you with the work, for sure. Okay. Yeah, don't worry. Actually, do you want to just pull out one of the questions that you were unsure about? We can take a look and see what we can untangle here. Yeah. Okay. So, actually, what's funny is in my free time, I actually make math videos on YouTube. So, I actually use this little setup. Do you want to use my whiteboard today? It'll be kind of fun. I have colored markers all over the place, but we can kind of play with it and pretend it's a video. But we don't have to, don't worry about it. But it's just a little setup math noteboard that I like to use when I explain stuff. Yeah, do you want to borrow one of my colored markers and write down the question? Oh, you'd prefer me to write it? That's fine. Here, just have your tea. Actually, I am so guilty of this. I'll pour myself a mug of hot tea, and then I'll go off and do stuff, and I'll forget about it. So I literally so you plugged the 2 into the x's, so 2 here, 2, 2, 2, and you got 0 over 0. And I see. You aren't sure if the limit doesn't exist then. I like to write everything like everything I'm thinking, so you think that the limit doesn't exist or you're not sure about that, because did you get 0 over 0 for all of the questions on your homework? And so then it started, yeah, that makes sense. Oh, that totally makes sense. That would be so confusing. Yeah, so let's take a look here. Okay, so let's see. Well, first thing is let's double check that it is 0 over 0. That's a really good instinct to substitute first. Yeah, that's great, because when you have a limit question, a lot of times you can just figure it out by substituting the value into it. But let's just check. So 2 squared is 4 plus 5 times 2 is 10. So 4 plus 10 is 14 minus 14 is 0. Nice, following order of operations. And then 2 squared is 4 minus 2 is 2 minus 2 is 0. Nice. Okay, so good, it is 0 over 0. So that means that we'll have to try another method. So it totally makes sense because dividing by 0 breaks math, right? We come into problems dividing by 0. So that totally makes sense why we'd feel like the limit doesn't exist. But there's actually just a little trick here. Do you remember factoring from algebra? Yeah, okay, cool. So that's all we're gonna do. So let's start by factoring these. Okay, and then we can kind of look at what we get. But what do you get if you were to factor x squared plus 5x minus 14? Like this stuff, remember? Minus 2 plus 7. Nice, awesome. Yep, because negative 2 times 7 is negative 14, and then you have the outer is 7x minus 2x for the inner. That gives you plus 5x. Great, awesome. Okay, so we're just going to factor the bottom as well. Do you see how to factor this one? Same exact way, right? Is it going to be negative 2 and positive 1, or negative 1 and positive 2? Negative 2, exactly. So the last part is negative 2 times 1 is negative 2. The outside is 1x minus 2x. The inner is negative 2x. That gives you negative x. Nice. Great. Awesome factor. I remember back in algebra when you worked so hard on this one particular homework, and it was so awesome because you really got it at the end. That's so cool. Okay, nice. So you can just try to factor this however you can, factor this however you can. We're gonna leave the limit as is. So now we actually see that we have an x minus 2 on the top and an x minus 2 on the bottom. What do you know? So, here, let's use some colors. Colors can make it a little bit more fun. We can actually cancel that out. The entire x minus 2 and the x minus 2. Because anything divided by itself just goes away. It's 1, right? So then 1 times anything just disappears. So then we can just look at this limit. As x approaches 2, and now we can substitute just like you did before to get the 0 over 0, but now we can substitute the 2 for x. So 2 plus 7 over 2 plus 1. Nice. And 2 plus 7 is 9. Exactly. 2 plus 1 is 3. So 9 divided by 3 is 4. necessarily mean that the limit doesn't exist. We actually do get a limit, and it is 3, 3, 3, 3. So yeah, do you have any questions about this? We went ahead and factored. And notice now that we canceled out the x minus 2, we don't have a part that has a 0 anymore. When you plug it in, you now have a number. Okay, so why does this not mean that the limit doesn't exist? Okay. Do you remember the movie Mean Girls? Yeah, it's funny. Okay, so do you remember that scene where Katie Heron is in Math Leads and she's like, the limit does not exist, and it's like this famous part of that, like everyone quotes it. Yeah, exactly. So I feel like because of that movie, everyone, like when they first hear about limits, they just want to say, the limit does not exist, the limit does not exist. So funny. But actually, when you have a 0 on the bottom here, it doesn't necessarily mean that the limit does not exist. It just means you have to go look for another method, and it might not exist, but that's not the reason. So just because it's undefined does not mean that the limit does not exist. So if, let's say, this top thing were 5 or like -1 or whatever other number other than 0, even if this bottom is 0, that's still problematic, right? Dividing by 0 is still problematic. But we'd have to go back and look at the question and do a little bit more work with it. Oftentimes that limit ends up being infinity or negative infinity. Sometimes it's undefined, but we can't really say. Kind of have to look at the original question. So when you see a 0 over 0, like you did when you substituted, that's perfect. That if you see 0 over 0 and you kind of see stuff that might look like it could be factored, like quadratics, or maybe a two-step factoring thing, or maybe difference of squares, difference of cubes, you're gonna have to remember those factoring techniques from algebra. You could always just look it up too, but that's the general idea. So if there are no like square roots, have you guys talked about conjugate pairs and stuff for that? No, not yet. I bet that's coming up soon, because this whole unit is basically algebra techniques to help you find limits. So conjugate pairs will be for square root situations, but if you see stuff like this and you're getting 0 over 0, it's a pretty good next step. So if substitution doesn't work, factoring might. Yeah. So I'm assuming you got like this kind of thing for all of your homework questions. That's awesome then. So we just have to focus on this method, and you're totally going to be able to do the rest too. Yeah, of course I'll look over it, but yeah, so it's the same idea. Oh, okay, so why can we cancel out this x minus 2 and this x minus 2? Okay, so it's on the top and the bottom, so those go away. Is that what you mean? Oh, okay, so how do you know if it's 0 over 0? That does not cancel, that's not 1. So how do you know x is not equal to 2? Oh, that's a really good question. How do you know that x is not equal to 2 itself? Because you couldn't cancel it if it were 0, 0. That is actually based on the idea of this limit. So we are not concerned about what happens at x equals 2 itself. The limit is about values of this thing as x approaches 2. Right? So we're talking about from the left, meaning values that are less than 2 but still getting infinitely closer. So like 1.999999999, and then values from the right, so infinitely closer to 2 but larger. So 2.000000000000001 or something, right? So not 2 but approaching infinitely closer from less than 2 and from greater than 2. So that means that we don't care what happens at 2 itself. So for any of those values, let's say 1.99999 minus 2, there's going to still be a difference. It's going to be a really small number. So it'll be negative point 0.00000000001 or something, and then divided by negative point 0.0000001. That's okay, right? That still is one that goes away as long as it's not 0 over 0. And same with the other. The difference is going to be really, really small, but it can still be cancelled, because the only time it can't be cancelled is if there is no difference at all, when it's exactly 0 over 0. But the limit kind of covers that. Perfect. Exactly. I know it's kind of hand wavy right now. It's not like the formal way of looking at limits, but that's the general idea, right? At x equals 2, it's a little discontinuity. Yeah, exactly. So actually the limit exists when the left and the right limits equal each other. So they have to approach the same thing for the limit to exist. So that's actually the real situation in which the limit exists, and if they don't approach the same thing, then the limit does not exist. So yeah, so this kind of implies the right and the left limits. You can look at one-sided limits, but this alone implies both. Exactly. So it'll never be 0 over 0 if x is not equal to 2. So, and we're not worried about that because of the limit. Perfect. And then you can just go ahead and substitute. So whenever it's just a number, let's say you substitute, you just get like 5 and 4. That is just the limit, 5 over 4. That's totally fine. If you have a 0 problem, you kind of have to go back and look. If you have 0 over 0 and it looks like you can factor, hopefully there will be something like this. And actually, if you think about it, when you plug in 2 minus 2, that's 0. 0 times anything is 0. So that's actually the piece that causes the problem. That's it. It's just this little piece. The x plus 1 causes no problems, because when you substitute 2, you get 3. So no dividing by 0 problem. So there's no way to get a product of 0 unless one of the things, or at least one of the things, is 0. Because, right, of course, a bunch of stuff that's not 0 multiplied together will never give you 0. So that means they're x minus 2, and if this is like any other constant, a, x minus a is the piece that causes the 0 problem. So that's actually the factor that we're looking for to cancel. That's the problem, so they can just pair up and go away. Go away. Yeah, exactly. And then it just ends up giving you a number. That's it. Yeah, it's very cool, right? So it seems like it's just like a headache, but it's just this little trick here. So you think you can try to apply it for the rest? Awesome. What a relief that it's just that. Nice. Okay. Yeah, feel free to, I mean, you don't have to take notes. I know. You can if you want to, though. Just jot this for an example for when you're back at it and working on it again. But you're smart. You've got this. You've totally got this. That's a relief. Yeah, so feel free to just review the factoring. I think that'll come back to you really quickly. Don't worry. I always forget the difference of cubes 1, that formula, but of course you can. Oh my gosh, you took all this time to come out here. Do you want to take a little nap or something? I can fix you up a snack and even pack you a little breakfast tomorrow before your class. Oops. Before your class. Yeah, of course. I love cooking. Here, why don't you make yourself comfortable? Lay down. I'll give you this pillow. can't sleep when you're actually supposed to be sleeping, so I just want you to be comfortable, just, half nap. Yeah. Okay, I'll tell you what. I will not sing you, but I will give you a little lullaby, if that's even what you want to call it. A math lullaby. And so I'll just do one more question, but just close your eyes. Close your eyes, lay down, close your eyes. And I will do all the work. And you can feel like you're kind of being productive, but you'll catch a little cat nap. How's that sound? I know, I'm such a good friend. No, I'm just kidding. So, alright, so let's look at this one. So I'll just do a similar question. How about a difference of squares one? Okay, so the limit of 2x squared minus 5x minus 3 all over x squared minus 9 as x approaches 3.